Hello, Cameron, Suzanne, and Emily. I wanted to take a quick video and discuss one of the questions Cameron had sent to me just to be able to clarify a little bit, point to some of the data, and get you guys going in the right direction. Cameron had sent me your hypothesis and also some of the PDFs showing the data that you were able to find on the CVCC website regarding student age and population. So I just want to highlight here that you guys had a prior estimate from 2016 for 24 years old. Then you're hypothesizing that the average age of students has increased. So you could take a look at 2017 data and see if it's increased. And it looked like the data that had been collected was going back to prior years, like 2013, 14, 15, and looking as well. So I actually really like the data. This is starting on page 6 of the 2013 data. It gives you lots of interesting things you can do. It looks like they've split things up into part-time, full-time, men, women, lots of different ways you guys can group the data differently and get some information. One thing that you could do from this is try to use the 3.3 methods for group data to get an average age. I'm not sure if they actually put this anywhere else in the report, like the average age that they found, but one way to think about the data you have here, if you were to compile full-time, part-time men and women, you have all of the ages of the students in summarized form. In other words, you don't have whether they were all 23, 26, 27, but you have information on their age categories, so you could estimate the mean for 2013, for 2014, 2015. That's actually really interesting and shows some neat applications of our 3.3 materials to this. You will have some issues here. Since this is just under 18, you probably want to put a cap on that lower limit, maybe 14 or 15, so that you have a range to work with. Same thing with the 65 and over. You'll need to somehow maybe think about a reasonable upper limit. You may have somewhere in the page that tells you the highest age, or you might have to think about what would be a reasonable number, because you can't really have an open-ended top limit for the 3.3 methods. So all of this is really good and things that you could put in your project to make a really dynamic and interesting review of the data you've collected. The component that your project would be missing with just the data that you have here is hypothesis testing and confidence intervals. In other words, even if you went through and found the average age for 2013, 14, 15, and any other years that you had, either year by year, or even if you put it all together for all of those years, either way, you still don't have a sample, because what you actually have is the entire population for 2013, 2014, 2015, and you don't have a sample to run a confidence interval on or a hypothesis test on. So this poses a little bit of a problem because we can't really take this data and do what we need to do. However, I did think about a data set that I have access to that is a collection of 80 student ages from fall 2017 from a collection of several online and seated courses. What I think would be a good thing is for me to share this data with you and you guys to use this as a sample of data from 2017 to create a confidence interval for the average age and run a hypothesis test. I'm going to pull this data up. So notice you've got ages here. I've got 48, 42, 42, a bunch of 18s, some 17s, so a variety of ages, and I believe there's 80. And this is not necessarily an ideal sample. I think there's 2 online sections and 2 seated sections here, but it's complete data from, I believe, 4 classes. So you could think about this as a sample and use these ages to estimate the true mean for fall 2017. Then you would compare back to that 24 average age from 2016. This would be a really nice complement to some of the analysis that you were doing from the previous years. In other words, the average ages based on the grouped data is interesting and maybe helps support the trend that you're trying to establish. So I think it's worth doing and worth looking at, but you also need that hypothesis testing component. So I will send you guys this spreadsheet. If you want to collect your own data for a sample in order to run the hypothesis testing or the confidence interval, you certainly can. But I think with the work that you've done and the data that I have, I feel comfortable with you taking this data and utilizing it to enhance your project and fulfill those components. So let me know if this makes sense. In other words, you will be using the spreadsheet to actually create a confidence interval, run a hypothesis test, and not the prior data from the populations from the years. All right, so I'll send that to you guys. Take a look at this. Let me know what questions you have. I'll also be sending out a frequently asked questions on the rubric, so that may help you guys as well to hear those points so you can think about how to organize your presentation, or excuse me, your report, and where all this fits in.